going to turn to specific applications of time value of money to the various segments that we have talked about, like most notably, say, stock pricing. How do we price stocks using concepts we've learned of time value of money or compounding, discounting, single sums, annuities? How do we use those concepts to think about what should be the present value of a stock or the price, current price? Present value is the current price of a stock, or what should a stock be worth in the future under certain conditions of growth and so on. And that's what the topic is right now. And so let's look at that, an example to get things started. So AH Incorporated paid $1.40 in dividends today. If that dividend is expected to grow at a constant 6% rate and the required rate of return is 13.5%, what should today's price be, or P0? In the lingo of time value of money and so on, current values, it's P0 that we are looking for. Now, I'm going to use for this purpose a formula that we've talked about when we discussed stocks, and this is the dividend growth model. And a dividend growth model, if you recall, we can think about the pricing of stocks as the discounted present value of all future cash flows occurring with that company. The complication is that we have to write that as an infinite sum or an unending sum because we don't know when the last date of a stock is, because we don't know how long the company will be in existence. And if you recall our discussion at that point, what we said was under some very specific assumption, namely, if the required rate of return is greater than the growth rate, or R is greater than G, using standard notation, then that formula, that series, that algebraic series that we saw earlier, reduces to a very simple form given here as PT equals dt plus 1 divided by R minus G, where PT is the price of the stock at time t, dt plus 1 is a dividend, and the next period, dt plus 1 divided by R minus G. So if we substitute in t equals 0 in that equation, we simply can rewrite that equation as P0 equals D1 divided by R minus G. So if we can then substitute what we are given information-wise, note that the company paid $1.40 in dividends today. That's code for D0. That means D0 equals $1.40. And therefore, D1 is going to be simply D0 times 1 plus G. Okay, so D1 equals 1 plus G because it's just a growth of a single sum for one period. When you do that calculation, it's simply D1 equals 1.484, which is simply 1.40 times 1 plus 0.06. That gives you the D1 value that we need. And then if you substitute that into the equation, your P0 is simply 1.484 divided by 0.135, which is the return in fractional form, minus the growth rate, which is 0.06. And the answer should be then, if you do the calculations, it'll be almost $20 or $19.79. So that should be the price. That should be, under these set of circumstances, assuming the assumptions are correct, the right value for that stock today is $19.79. So let's look at another example. This company, Bad Wolf, paid a $2 dividend today. Again, that means D0 equals $2. If the dividend is expected to grow at a constant 5% rate, so again, G is 0.05, and the required rate of return is 10%, or R is 0.10, what should today's price be? Again, a straightforward application of that above formula, which you can now should be comfortable doing. Here's another example. Make More Incorporated pays a dividend today. The dividend is expected to grow at a constant 5% rate. Again, it's the same kind of application with different numbers, and you should be able to practice and get your ideas worked out in your head. Here's another example that says the current stock price of Anheuser-Busch is $50.65, and they just paid a $1.32 dividend, which is again code for D0. If the required rate of return is 7%, again, that's the R. What dividend growth should investors expect? So this is a slight twist to the problem, right? Here we are given everything else but G, and we are expected to solve for G. Again, understand that the formula that we're given on this slide, it only holds, is valid under the assumption R is greater than G. Because obviously, if R is less than or equal to G, we have a denominator that is zero. And then we have some very funky things happening in math. So we want that denominator to be positive, which means R needs to be greater than G for this whole thing to work. So you can actually play around with that formula by moving it around to isolate G, which is what you solve for. And then you will see that it'll actually be a quadratic equation. So it's a non-trivial problem that you can use a financial calculator to solve, because you're going to have G raised, it's going to be a quadratic equation in G, and you're going to have two possible solutions. Hopefully one of them is going to be the positive one that you need, the other one you can reject, and you can solve for this problem using that formula. Good luck.